So, hot topic 9. We're starting to get through them. Aerobic, anaerobic. Do you know the difference? Did you know that an is without? Bit of Latin there for you. So that is aerobic is with oxygen, and anaerobic, we've got that aerobic with oxygen, the an means without, so it's without oxygen. Make sure you know the correct way round for that. So we are now completing the table. Excellent, going through there, showing aerobic and anaerobic respiration. So let's have a look. Starting here, type of respiration. Let's see the clues here. Long duration. If it is long duration, it's got to have oxygen. It's aerobic respiration is something you do all the time. You are getting that energy to in your muscles through the oxygen. It's not going above and beyond. It's just your normal practice. So long duration is aerobic. Let's carry on with our aerobic respiration then. So we have got glucose. I've already said it's with oxygen. Glucose plus oxygen, and that is creating carbon dioxide and water. And then that is going to allow the energy release. So that is our aerobic. And so we've got this one. And finally, we need to talk about the intensity. If it is long in duration, then it is going to be low intensity. You might also see moderate. You wouldn't be able to keep up with that 100-meter sprint for 26 miles. You wouldn't be able to keep up with that pace. So it's got to be a low intensity, which is why our marathon runners aren't running as fast as our sprinters. Let's move on to the second one, B. Now, process of elimination, we've got anaerobic, but you can also use clues such as short duration, the lactic acid, and just glucose, and there's no oxygen there to help you. And then with our intensity, this is having to work really hard. Short duration, because you can't manage it for very long. So it is a high intensity. Let's scroll on down. Let's look through. Here you go. So I've already gone through the durations and stuff, but let's look back. We've got aerobic respiration. It is long and it is low intensity. So our example in basketball, imagine you're playing a defensive position and it's zone defense. So you are selecting defensive position, zone defense, and the ball is on the other side of the court. So here you go. Here's my basketball court. The ball is just there, and you are just here in your zone defense. You are not needing to work quite so hard because the ball and play is over here. So you've got a little bit of time. You can get that recovery. You're not working as intensely. Let's look at our badminton. Our badminton here, very similar. We've got our badminton court just here. Probably didn't need to draw the whole badminton court there. But we've got our player hitting the shuttle there. And then they're going to hit it from here. And then over from there. And then there. So it's a back court rally. It's long, it's slow. They're not having to work too high intensely. So that's using those aerobic respiration because you've got all that oxygen. And then finally, I think marathon is the key and obvious one for this because you're maintaining that steady pace. But it's really good practice to do that badminton and to practice that basketball. It's just making you think outside the box. Let's go on to our anaerobic respiration just here. It is shorter because again, think high intensity, you can't last very long, so it is short. And this is all about as you said, the high intensity, fast breaks. It might be something that's quick, good, all those adjectives, those synonyms, words that mean the same thing. So fast, quick break down the court. So you were just here, you're then sprinting down the court maybe to help out. That's your sudden high intensity. That is now using your anaerobic respiration. If we move over to badminton, I'm going to draw a slightly simpler badminton court this time. Just here. My dad used to do this to me all the time. It infuriated me. He would push me to the back of the court. I would hit it back, and then it'd do this little tiny drop shot. So I'd have to sprint there. I'd give it back to him, and then he'd hit it in another corner. So then I'm having to sprint. I was having to work hard. I couldn't keep it up for very long, so it was really short, but I was working at a really high intensity. So key word just there is that quick sprint, and we're linking it to badminton. So we've talked about that drop shot. And then the marathon. Marathon, easier to describe with aerobic respiration, a little bit harder with anaerobic respiration. We talk about that quick sprint. You might not realise that in marathon running, you do still have to do some sprinting. It might be to the finish line, to beat your opponent. You might be sprinting at the beginning just to get ahead of the pack. If you think all these people just here are all starting together, these are people, by the way, if you can't tell, and this is you. You want to be getting this way, you've got to get through all those people. So you might do a quick sprint and then they're not in your way anymore. So you've got the whole route to go at your pace. You're not stuck behind people. So that's a really good way of doing that anaerobic respiration in a marathon runner. Let's continue to scroll down to this question. Now, oxygen debt, which is what we're talking about here, is not technically in this section, but I think it's really good for you to make sure that you are linking oxygen debt with anaerobic respiration, anaerobic exercise. So again, we go through, we describe how this time, describing how. So describe how a performer repays oxygen debt after anaerobic exercise. I'm sure you've all done this. You've worked really hard for a really short amount of time, a sudden sprint, really quick. And at the end of it, you're really noticing you're gasping for breath, deep breaths. So gasping to get that oxygen, you're doing deep breaths. And that is to try and repay that oxygen debt. You're trying to get that oxygen back into your muscles so you can go back to that aerobic respiration. So it is going to be here, something by continuing to breathe at a something rate or something, then at rest, and also keeping what. So what do we think the answer is going to be here? I think it's really key to make sure that you think about, even though this is a new, well, not a new topic, but even though this isn't anaerobic, you still need to make sure you are linking it. So I talked about oxygen debt happening. It is after you've finished that high intensity. So we will look at post-exercise. So post-exercise, by continuing to breathe out. Now I talked about deep breaths, gasping. I'm going to write a greater depth. So continuing to work at a greater depth than at rest. So you normal breathing, but at that point you're having to breathe much deeper. And then also keeping, it's your heart rate, because we're wanting to get that oxygen back to those working muscles to repay that oxygen debt, to recover that deficit. So you've got to have your heart rate above resting levels, because that's one way that you're getting your oxygen to those working muscles. We're on to hot topic 7, good old muscle fibre types. Remember, we have got 2 different types. We have got our fast and our slow. And some interesting things for you to start to think about. Identify. Can you identify the different muscle fibre types? Could you describe them? Can you explain them? We're going to go into a bit of explain later. And another question that I've seen on the iGCSE is compare. So these are your different skills, the different command words that you might need to talk about muscle fibre types. So make sure you're practicing that before your exam. We are going to go down. As usual, we've got a question. Identify. So identify one named feature of fast twitch. But identify my square, shouldn't I? And then explain how. Explain how it would benefit the following performances: marathon, sprinter, high jumper. So, feature of fast twitch. We have got low fatigue resistance. Going to give that a tick. Remember, fatigue resistance is if you don't get tired. So don't get tired. So if I write fatigue resistance at the top here, and then, so we know that that's don't get tired. So the opposite is tires quickly. I do my little scale. There you go. This is high and this is low, which means our low fatigue resistance means someone who tires quickly. This always throws me and I always get really confused by this one. So do make sure that you know low fatigue resistance, they tire quickly. You could have also answered with high force production. High force production. There you go. So they can create powerful, explosive movements. Or you could have written predominantly, if I can spell it, predominantly anaerobic. Good 2 other options there. And remember, if it's anaerobic, it's really short. So our 100 meters and our high jump, again, really short, explosive events, 10, 15, 20 seconds. So they work there and they really benefit from the fact that the tires quickly, actually quite useful. Right, marathon runner. Let's go through that. I have written support slow twitch muscle fibers when they are able to. Would you give the mark? Does it give the benefit? Does it explain how? I think we need a little bit more detail. So support slow twitch muscle fibers. I'm going to write to delay fatigue over the long distance. So it's all about helping to put off that fatigue. Marathon run, 26 miles, 26.1 miles. It's a heck of a long way. So our low fatigue resistance means that they are able to delay fatigue. So they can carry on going for longer without tiring. So I think that's quite a tricky one. Let's move on. Let's go into red. 100 meter sprinter. Now, if written doesn't have an impact, you will not get a mark for something that simple and that vague. It asks you to explain. So let's go on and add due to. So it's not wrong, doesn't have an impact, due to. Why? Because it's a short event. It's a short event and it doesn't require fatigue resistance because it's such a short event. So you're not going to tire in the 100 meters. You're not going to suddenly think, oh my gosh, I can't cope with this anymore. It is a short event, so it doesn't tire. So you don't need to worry about that. And then let's move on to high jumper. It doesn't have an impact. Again, I've said this is going to get you the mark. Let's write because. Let's underline that. Because, again, very similar. Because of the quick, explosive nature of the high jump. So, of the event. So that's how you would go from not getting the mark here and here to getting all 4 marks. Let's move that page down to here and have a look just here. Justify key thing to be able to do. So why, and I think it says in a named sport, so I'm going to go with tennis. Why do we want a slow muscle fibre type for tennis? Well, because it's a long game, a long match. Often 2 hours plus. So you need to be able to do repeated contractions without getting tired. Repeated contractions without fatigue. So your performance doesn't drop. So performance doesn't drop. So that's really key just there. A long match. Let's go through a long match. Repeated contractions without fatigue. Those contractions are going to not be that strong. They're going to have that low force, but we want that high fatigue resistance, which I've just talked about just here. Moving on to our fast twitch. Why do we need them in tennis? because of a sudden sprint to a drop shot, or it might be a powerful smash, all need explosive high force to be able to complete that skill, but they will tire quickly. So it's just a short burst of energy. You need an explosive high force and burst of energy. There you go. Topic number 3. Let's just scroll so we can try and see the whole thing. There you go. So we are looking at gaseous exchange. Key things to know all about those alveoli. So these little cauliflower, broccoli type things here, they are 1 cell thick. I think I'm going to say that expression a lot today. If anybody can count up how many times, I'm sure we can get some sort of prize or shout out to you. They are 1 cell thick. So it starts here with our 1 cell thick alveoli. And they are surrounded, so do make these notes as I am as well. They are surrounded by, funnily enough, 1 cell thick capillaries. So there's a really thin pathway between and through the alveoli to the capillaries. Let's move down to number 3 over here. I'm going to call them RBC. You should be writing red blood cells, but they now enter the capillary, which is excellent. And they are carrying, again, I am going to write CO2, but carbon dioxide at a higher concentration. So our red blood cells entering the capillaries I've got a higher concentration than the alveolus. And so remember, alveolus is 1, alveoli is many. So we have got here our red blood cells. You can see them. I really want to be in red for this. So our red blood cells, taking far too long, our red blood cells coming through just here. And then we are getting to that sort of concentration gradient. But first we need to talk about our oxygen. Let me go back to green. So O2, oxygen, in our alveoli, or our alveolus, because there's just one, is in a higher concentration. So in our alveolus, we've got a higher concentration in the alveolus than in the blood. So this means we're going to start. So we've got lots of oxygen here. We've got lots of carbon dioxide here in those red blood cells, and we're going to create that net movement across that concentration gradient. So it's going to say net movement of both, and it's both O2 and carbon dioxide, goes from high to low. So let me write that out, high to low concentration. So for those of you that aren't sure, let me go through and quickly talk about diffusion. So our diffusion gradient, again, we go from high to low concentration. Key thing to know, and to make sure you're writing in your answers there. So we've got that net movement of oxygen and carbon dioxide going across that membrane from the alveoli to the capillaries and capillaries to the alveoli. And then we end up with red blood cells, which are now rich in oxygen. So they are now oxygenated because that oxygen has gone from the high concentration in the alveoli to the low concentration in those red blood cells, but then it's gone across and it's now all in those red blood cells, and it's now going to be returned to the heart to be able to be pumped on, returned to heart to be pumped on to our working muscles. Let me scroll down. Let's have a little look at here. Can I fit this all on one page? I can. Fantastic. In fact, I'm going to change the colour again. So we've got here high concentration of oxygen. How does that impact the rate of diffusion? Well, it causes a concentration gradient. A concentration gradient between the alveoli and the capillaries. Between the alveoli and the capillaries. And that allows that movement across from those alveoli to the capillaries. Another key thing about the structure is that there's so many of them, and because there's so many of these little cauliflower type structures, we've got a large surface area, and if it's got a large surface area, it then causes a greater rate of diffusion. So effectively, diffusion can happen more because you've got that larger surface area, and that's only a good thing. Then we get 1 cell thick. It really should be 1 cell thin, but anyway, this means it's a shorter diffusion pathway. They don't have to go very far. I don't know about you, but if you've ever gone on holiday and you've entered the airport, it's really nice when you don't have to walk very far from the airport to the gate. So if you've got a long pathway, but if you've got a nice short pathway, it's nice and efficient. And that's just like that 1 cell thick, a shorter diffusion pathway. Basically, it means it's really efficient and it increases the rate of diffusion because more can happen. Increases rate of diffusion. Then we go on to being surrounded by capillaries. This means that we've got a constant refresh of blood, constant refreshing of blood, which means that you're getting more oxygen, more carbon dioxide crossing across that concentration gradient. So constant refreshed blood supply. And then so basically it means, so it maintained, I'll write it down as well, maintained the diffusion gradient because it's constantly being replaced and refreshed. Gradient. There you go. And then a moist, warm environment. Lovely environment. Basically, it just means that everything can go on and it can all happen. So it's perfect conditions that allow diffusion to occur. Perfect conditions that allow diffusion to occur. There you go. And then we've got our exam question. So let's answer that in blue. Again, we look at suggest the features of the alveoli that benefit a triathlete during the process of gaseous exchange. So looking at the answers above, we've got a large surface area of the alveoli that causes the diffusion rate to increase. We've got a large number. What have I got? A large number of capillaries. A large number of capillaries that surround the alveoli that also promote diffusion, and they also provide that constant. So you'll notice I'm just taking the different structures here. The constant refreshed blood. So if you can know all this, then you are going to be winning that battle to maintain the diffusion gradient. And then finally, they are, how many times have I said this? 1 cell thick, which means the diffusion pathway is very short. So we've taken the knowledge from above and we have put it into that question below. If you didn't know any of this, Make sure you are reading through it and you're going through it over and over again.